Okay, so sound, it's everywhere.
Right.
But think about it like a philosopher for a second. It gets weird fast.
It really does.
We rely on sight so much. Seeing is believing and all that. But sound is different. It unfolds over time. It hits us right in the feels. It builds entire worlds in our minds. There's so much there to explore philosophically. You're going to love this.
I think I am.
Today, we are diving deep into the very essence of sound. Like, what are these things we hear?
Right.
Are they physical things? Are they events? Or are they something else entirely? Get ready, because the philosophers have a whole lot of different answers.
Oh, they do. And that's what makes it so fascinating. We think we know sound. It's basic, everyday experience, a bird chirping, a car horn. But when we ask, what is it, really?
Right.
It opens up all these philosophical questions. Questions about perception, about reality, even about space itself.
Exactly. We are not going to get bogged down in technical jargon today. Think of this as your fast track to the main philosophical debates about sound. Basically, where is it? Is it inside us, the hearer? Is it out in the world, at the source? Or is it somewhere in between?
I like it.
So to map it out, we're going to look at 4 basic categories of theories. Those that say sound is right here with the hearer, what we'll call proximal. Those that say it's in the medium, like the air that's medial. Those that say it's at the source, way over there, distal. And then get this, those that say it's not actually spatial at all, espatial.
Excellent framework. Makes things much clearer. So let's start right in with the proximal theories, the ones that locate sound with the hearer.
Sounds like a plan. The basic idea here is that sound is literally right at or inside your body. It's all about you, the listener.
Right, and the most basic version of this is the idea that sounds are just sensations, internal states or properties. They happen when those sound waves hit your ear.
It's kind of like indirect realism, right? That philosophical idea that we don't experience the world directly, but through our senses.
Exactly.
Okay, so as a philosopher, you know our senses can be a little unreliable. We hear things that aren't really there, like tinnitus, that ringing in your ears after a concert, or those weird sounds people report in anechoic chambers. There's even the story of Shostakovich, who said he could hear entire melodies in his head just by moving it around. These feel like real sounds, but there's no external source. So maybe, this theory says, all sounds are like that. They're just internal sensations that happen when sound waves hit our ears. So the sound is this sensation, and it's how we experience a distant philosopher making a point.
Right. Like, have you ever heard one of those phantom sounds, a tone that just appears and then disappears? This theory tries to make sense of that kind of subjective experience, but there's another proximal view, a little different. It says that the sound you hear is where you are, even if the source is somewhere else.
Right, right. O'Shaughnessy, he says, and I quote, "The sound that we hear is nonetheless where we are."
Yeah.
Strong stuff.
So imagine a motorcycle, super loud when it's right next to you, but when it's far away, it's just a rumble. What's happening at your eardrum is totally different in those two situations. But O'Shaughnessy would say, the sound you hear is right there with you both times.
Makes sense.
It's like that party upstairs, right? Sounds totally different to the people at the party than it does to the person trying to sleep downstairs. The proximal view says the sound is relative to where each listener is.
Interesting. But there's a problem. If the sound is tied to the hearer's location, how come we experience it as coming from a specific place out in the world? Like, we don't hear the motorcycle sound in our ears, we hear it coming from down the street.
Good point.
Critics say you got to separate the information channel, like the sound waves, from the source of that information. It's like seeing a reflection. The light hits your eye, but you see the object as behind the mirror, not on its surface. Maybe sound is similar.
I see.
The waves carry information about where the sound is coming from, and we use that to figure out its location.
Okay, I can see that. But then there's the issue of how we perceive the qualities of a sound, even when it's far away. Like, we know that a motorcycle far away is still loud, even though the sound reaching us is quiet. We have a sense of its real volume. How can we do that if the sound is just a local sensation or stimulus?
That's another tough one. And remember, these proximal theories, whether they're about sensations or proximal stimuli, they kind of end up with some weird consequences. Like, either there are as many sounds as there are listeners,
Right.
or a single sound is somehow in multiple places at once. It's hard to wrap your head around that. But for a philosopher, the biggest problem is that this whole approach leads to what they call a massive error theory.
Oh, yeah.
Our everyday experience says that sounds are usually out there in the world, not in our heads. But if proximal theories are right, then we're basically wrong about the location of pretty much every sound we hear.
So not very satisfying, huh?
Yeah, it's a tough sell. So let's move on. Maybe the answer is somewhere in between. That brings us to the medial theories. They say that sound is in the medium. Usually that means the air between the source and the listener.
Ah, okay, so like sound waves traveling through the air.
Exactly. And this idea has been around for a long time. Aristotle, he said sound was a certain movement of air.
Interesting.
Now, he didn't say sound was air, but it was definitely connected to the air's movement. Then, in the 17th century, you have folks like Galileo and Descartes really pushing this idea of sound as a wave, some kind of disturbance or motion in the air that reaches our ears.
Makes sense.
And Mersenne, he actually went and measured the speed of sound.
Wow.
So Galileo, he talked about the air being ruffled and creating waves that hit our eardrums, and he thought the frequency of the waves determined the pitch. Descartes, he was on a similar track. He thought we hear these movements coming from objects.
Fascinating.
But even back then, some philosophers realized that this view was pretty different from our common sense understanding of sound.
You mean like if the sound is the wave, how can we hear it coming from the object, not from the air?
Exactly. It's like the proximal theories, right?
Yeah.
They're suggesting that maybe the real nature of sound is a bit more complicated than it seems. And get this, Galileo might have actually believed in both proximal and medial views at the same time. It just goes to show how tricky this issue is.
Wow, that's interesting. So where do we stand today with the whole wave theory?
Well, in modern acoustics, waves are everything. It's how we understand sound now. Sound is mechanical vibrations moving through a medium, like air or water. They have a certain frequency, which gives us pitch, and amplitude, which gives us loudness.
Okay.
When something vibrates, it creates a disturbance. This disturbance spreads out as a wave. We can picture it as a series of compressions and rarefactions in the air.
Like ripples in a pond.
Exactly.
But for philosophers who like physicalism, the idea that everything is basically physical stuff, this view is really appealing. Sound is reduced to these airwaves, and that's it.
Absolutely. You've got philosophers like Nuds, Calderon, Meadows, all in that camp. Perkins, he says it straight up. The sound we hear is identical with the train of airwaves that stretches from the distant sounding object to our ear.
Wow.
That's a bold statement.
It is. So are they right?
Well, there's a lot going for the wave theory. It explains a lot of what we hear, like the connection between frequency and pitch, amplitude and loudness, why we can tell which direction a sound is coming from, and then there's the Doppler effect.
What's that?
That's when the pitch of a sound changes because the source is moving. You know, like an ambulance siren,
Hmm?
higher pitch as it comes towards you, lower as it goes away. The wave theory explains that really well.
I see.
It's a much better fit than trying to explain colors with electromagnetic waves.
Okay, so it's a pretty good theory then.
It is. But, like any good theory, it has some problems too. For instance, sometimes we hear two sounds as the same even though the waves are different. They call that metameric sounds. It means that there's not always a perfect match between the waves and what we hear. Then there's the question of ultrasounds and infrasounds. We can't hear them, but physically they're just like the sounds we can hear. Vibrations in a medium.
So are they sounds?
Good question. And then there's the relationship between the wave and the object that made it. The theory doesn't really tell us how those are connected. Like, does the wave need the object to exist? We kind of assume it does, but the wave theory doesn't really answer that. But the biggest philosophical problem for the wave theory is location.
Ah, right. If the sound is the wave, then it should be in the air between the source and our ears. But we usually hear it as coming from the source itself. Like we hear the bell ringing, not the air vibrating.
Exactly. It's that massive error theory popping up again. It's a tough one.
It is. And then there's the question of what waves are. Like, are they a process, something that changes over time and space? If that's true, do they even really move? Or are they some weird kind of individual thing that can move?
Right. And if they do move, why don't we hear them moving? Except when the source is moving, of course. Like with light, we see the source emitting light, but we don't see the light itself traveling through space. Maybe we hear the event that makes the sound, not the sound wave itself.
That's a thought.
And this brings us to the idea of audible information. For us to hear sound waves, they would have to be carrying the information that we actually hear, but they don't seem to. We hear sounds, so sounds can't just be sound waves.
It's almost like they're a step removed, right? The wave carries something, but that something isn't the sound itself.
Yeah, something like that. And there's some other arguments against the wave theory, too. Like sometimes you can tell the difference between a loud sound far away and a soft sound nearby. Even if the waves hitting your ear are the same strength, we hear the real volume no matter how far away we are. And think about it, we hear a sound as having the same loudness even as the source moves away from us. That means different sound waves are creating the same sound in our experience, and the same wave could even create different sounds, a loud one far away or a soft one close up. It's
Right.
weird.
It is.
And then there's the classic vacuum argument. We all know the story of the bell in the jar. When you suck out the air, you can't hear the bell anymore. That seems to say you need a medium for sound to exist.
Right.
But some philosophers would say, wait a minute, is that really true? Maybe it just means we can't hear the sound without air. Like colors still exist in the dark even though we can't see them. Maybe it's the same with sound.
So sound could exist in a vacuum.
Maybe. But the problem remains that our everyday experience as sound is located at the source. So if the wave theory is right, then our perception of sound is fundamentally messed up.
It's that massive error theory again.
Exactly. And so we come to the next big category, the distal theories. These theories put sound right where it seems to be, at the source, the object making the sound. Ah, okay. So if a drum is making a sound, the sound is actually at the drum, not in the air between the drum and our ears.
Right. This is way more intuitive, right? And there are a few different versions of this distal view. The first one is the property theory. It says that sounds are just properties of objects, like color and shape.
Like a red ball is red.
Right. And philosophers have been flirting with this idea for ages. Galileo, Locke, they all talked about sounds as secondary qualities.
What does that mean?
Basically, it means they are qualities that depend on the object and how we perceive it. Like a red ball doesn't have redness in itself. It's just reflecting certain light waves that we perceive as red. And more recently, you have folks like Pasnow and Leddington who have defended this view. Leddington, he says, sound is a property of the event that creates it. So the sound of a crash is a property of the crashing event itself. I see. But there's some problems with that view, right? Like we say things make sounds, not that they have sounds.
Yeah.
Like a drum doesn't just have the sound of a drum beat. It has to be hit to make it. It's not like color. A red ball is just red. You don't need to do anything to it.
I know what you mean. And sound seems so different from something like color or shape. It happens over time. It has a beginning and an end. It's dynamic.
Right.
A red ball is just red. It doesn't change. But a sound is constantly changing as it plays. It's a whole process.
Okay, yeah.
But some philosophers, like Roberts, argue that these differences aren't as big as they seem. And Cohen, he says that just because sound unfolds over time doesn't mean it's fundamentally different. Di Bona and Santangelo, they even suggest that how we experience sound over time might be kind of similar to some ways we experience color.
That's interesting. But there's another distal theory, right?
Yeah, the located event theory. This one is pretty popular. Casati and Dokich are big proponents, and so are Pasnow and Rodin more recently. They say that sounds are events, things that happen to objects, and these events are located at the source. So the vibration of the drum is the sound,
Okay.
and the air, it's just the messenger carrying information about that event to our ears. But the sound doesn't need the air to exist.
So it could exist in a vacuum.
Exactly. And this theory explains a lot of the stuff that was giving the medial theory trouble, like the fact that sound doesn't seem to move the way vibrations do, and that its loudness stays the same at the source even if we move farther away. Plus, it nicely explains sound as a process that happens over time, which fits with how we experience it. It's like a neat little package.
Okay, so we're not just hearing the sound waves, we're hearing the event that created them.
Exactly.
I like it.
Yes.
But are there any objections?
Oh, there are always objections in philosophy. One is, if the sound is at the source, how do we explain when we mishear the location? Like when we hear rain as being below us, when it's actually above. Or echoes. If the sound is just at the source, why do we hear it in multiple places?
Good questions.
Well, the located event theory has an answer for that. It says that mislocation is kind of like seeing something in a mirror. We see the image behind the mirror, but the object itself is in front. The light just takes a roundabout path.
Right.
It's the same with echoes. The sound waves bounce around and trick our ears, but the sound itself is still just at the source. They call this the mirror sophism. Deviant wave paths cause us to misperceive the location, but the wave paths aren't the sounds themselves. Then there's the Doppler effect. That seems to be all about the waves themselves changing. The distal view says, hang on, the sound itself isn't changing. Like, if you're on a moving train and a trumpet player plays a note, the note stays the same.
Yeah.
It's our perception that changes because of the relative motion. Our hearing gets sort of distorted because the source is moving.
Oh,
And there's another objection. Sounds have qualities, like being high or low pitched. But events at the source aren't literally high or low.
good point.
The response is that we can connect those qualities. High pitch means fast vibration. And sound waves themselves aren't literally high or low. Those terms describe their frequency.
Right, right.
And of course, there's the causal objection. How do we actually hear the event at the source? The waves seem to be the cause of our hearing. The distal view argues that it's like with light. Light is what allows us to see a surface, but we don't actually see the light itself, except if it's like a light bulb. The sound waves are how we hear the event, but they're not the sound itself.
Okay. What about when we say the sound filled the room? Does that mean the sound event is spread throughout the whole room?
Not really. The theory says that's just a way of speaking. It means you could hear the sound from anywhere in the room. The sound event is still located at the source. Like with thunder, it seems to fill the whole sky. But actually, it's just a really localized event, the rapid heating of air. That event makes the air vibrate, and those vibrations spread out.
I see. So are we done with distal theories now?
Not quite. There's another one, similar but different, the relational event theory. This one's O'Callaghan's baby. He says sounds aren't just events happening to an object, they're relational. They involve both the source and the medium.
Interesting.
So the medium isn't just a passive thing, it's actually part of what makes the sound a sound. And that means sounds can't exist without a medium. No vacuum sounds for O'Callaghan.
Okay, so he kind of agrees with the medial theory on that point.
Yeah, kind of, but there's a problem. We can tell the difference between a sound stopping because the source stops vibrating and a sound stopping because something is blocking the waves. Like imagine plugging your ears. O'Callaghan's theory might have trouble explaining that. If the sound is the disturbance of the medium, then shouldn't it stop completely if the medium is blocked?
I see. Yeah.
It's like the sound in a vacuum jar. If you suck the air out and then let it back in really quickly, does the sound stop and start? Or is it always there, just unable to reach our ears when there's no air? If it's always there, that's a problem for the relational event theory.
Tricky. But does this theory have any advantages over the other distal one?
Maybe. It gives us a way to tell which vibrations at the source actually count as sounds. It's the ones that create those disturbances in the medium. The located event theory doesn't really give us that.
Ah, so it's more specific.
Yeah.
I see. But they both have to explain how sound and the source are related, right?
Absolutely. For the relational event theory, it's pretty simple. The sound is part of a bigger event that includes the source. Like a bell ringing is one event, and the sound is a part of that event. They call this the Mariological view. It explains why we see the sound and the source as separate things, but also as part of one whole thing.
I can see that.
Now, the located event theory often goes for a bolder claim. They say the sound is the event at the source, like literally the same thing. This is called the identity view. They say the vibration of the bell just is the sound, simple and clean. And they argue it fits better with how we experience sound as this unified thing.
Okay. So 2 different ways to think about the relationship between sound and source. Got it. Are there other views on this?
Oh, yeah, there are a bunch. Some say we hear both the sound and the source directly. Others say we hear the source by hearing the sound it makes. Others say it's all about cause and effect. The debate goes on.
Of course it does. It's philosophy.
Exactly. And there's some bigger criticisms, too. Some argue that these event theories are too narrow. They might not include all the things we call sounds. Like a dog barking is different from the sound of footsteps. One is made by a vibrating object, the other isn't. And if sounds are located at the source, how do we explain recordings or echoes? Those are sounds, but they're not happening at the original source. These are big philosophical puzzles.
They are. So are there any other distal theories? Or are we moving on?
Well, there's one more, and it's a bit of a wild card. It's called the dispositional view. John Kulvicki is the main guy behind this one. He takes that analogy between sound and color and runs with it. He says sounds aren't events, they're dispositions. A disposition is like a potential. So a red object has the disposition to reflect red light, and a sounding object has the disposition to vibrate at a certain frequency when it's, well, thwacked, is how he puts it.
Thwacked.
Yeah.
Okay, so like a drum has the potential to make a drum sound when it's hit.
Exactly. And Kulvicki says these dispositions exist even if they're not being realized. Like the sound of a bell exists even when the bell isn't ringing. Just like a red ball is still red in the dark even though we can't see it.
Okay, but if the sounds are dispositions, what about the waves?
The waves are just how we hear these dispositions, like shining white light on a red ball is how we see its redness.
Ah, I see.
And he says a good thwack, one that includes all frequencies, is like white light. It reveals the full range of the object's sonic potential.
That's a cool way to think about it. And I guess it makes sense that sounds would be tied to objects like that. It fits our intuition.
Yeah, and it also highlights that we often have to do something to hear a sound. We hit things, pluck strings, whatever. We're interacting with the object's potential to vibrate. Hearing a sound on this view is about learning how an object responds to being stimulated. Like when we say a guitar string is tuned to a sharp, we're describing its disposition to vibrate at that specific frequency.
I see, yeah.
Kulvicki even connects this to color constancy, the way we see an object as having the same color even in different lighting. He says we have something similar with sound. We can recognize someone's voice even if they're talking loudly or softly. That suggests our hearing is tuned to pick out these stable underlying properties of objects.
That's fascinating. But does this view have any problems?
Oh, you know it does. For one, objects have lots of different ways of vibrating. Depending on how you hit them, they'll sound different. Are all those potential vibration sounds? It seems like there would be way too many sounds. Kulvicki tries to deal with this by saying there's a normative way to thwack an object, but it's a bit fuzzy what that means. Another problem is what he calls occurrent sounds. What exactly is the sound we hear when the object is actually vibrating?
Yeah, what is it?
Well, Kulvicki says there are no individual sounds, just us hearing the object's disposition, but that seems weird. Like, imagine a tuning fork vibrating for 30 seconds, but you only listen for 10. Did the sound just stop existing for those other 20 seconds, even though the fork was still vibrating? It seems like there should be sounds that aren't being heard. Kulvicki says no, but it's hard to swallow.
Yeah, we get that.
And then there's the issue of time. Sounds unfold over time. They have a duration. But dispositions don't really work that way. Kulvicki tries to fix this, but it's not really convincing. It's like he's trying to force the square peg of sound into the round hole of dispositions. More recently, he's broadened his view, but it's getting a bit messy. It's like he's listing all the things we hear, but not really telling us what sound is.
Okay, so we've looked at proximal theories, medial theories, and distal theories. We've gone from sounds being in our heads to sounds being vibrations in the air to sounds being at the source.
Yep, a wild ride.
It is. And they all assume that sound has a location, right?
Right. They all say that spatiality, the awareness of sound, is crucial for figuring out what it is. It matters for how we separate different sounds, for how we experience music, even for how we understand the size of an empty room.
Okay, but there's another category, right?
Yeah.
The one that says sound isn't spatial at all?
Ah, yes. The aspatial theories. These are the rebels. They say, what if we're thinking about sound all wrong? What if it's not about location at all?
That's a pretty radical idea.
It is. And Peter Strawson is one of the big names here. He argues that sounds don't have any inherent spatial properties. Words like left, right, near, far, they don't really apply to sounds in themselves.
Wait, what? But how can we say where a sound is coming from then?
Strawson says we learn those spatial words from our other senses, like sight and touch. And then we just associate them with sounds. It's not the sound itself that has a location.
So it's like we're projecting our spatial awareness onto the sound.
Exactly. And he even has this crazy thought experiment to illustrate his point. He imagines a being, Hero, who lives in a world of pure sound. No sight, no touch, just sound.
Cool.
And to make sense of this world, Hero uses a master sound, a kind of constantly changing tone. He uses the changes in this tone to map out where different sounds are relative to each other. It's like a spatial map, but made of sound.
That's mind-blowing.
It is. But other philosophers, like Gareth Evans, they argue that this master sound idea is too weird. It can't really do the same job as our concept of physical space. And it's important to remember that Strawson isn't saying that there could be a world of only sounds, just that we can have auditory experiences that aren't spatial. Like, you can focus on the quality of a sound without thinking about where it's coming from. That doesn't mean the sound itself doesn't have a location.
Okay, I see. So it's more about how we experience sound, not necessarily about the sound itself.
Exactly. Then you've got O'Shaughnessy. He says, yeah, we hear that a sound is coming from somewhere, but we don't experience it as actually being anywhere. He argues that we never directly perceive the location of a sound.
But then where does he say the sound is?
Well, he ends up back with a proximal theory. He thinks the sound is with the hearer. So for him, our perception of sound as being located at the source is an illusion. Back to the massive error theory again.
Oh, we can't seem to get away from that, can we?
Nope. It keeps coming back. And lastly, there's Roger Scruton. He's got a different take. He looks at music and he says, listen, When we hear music, it's like the sounds are detached from their physical cause. It's like they become their own things.
Mm.
He calls them pure events, things that happen but not to any object. And secondary objects, things that depend on our perception to exist. It's a very non-physicalist view. But maybe we can make it work with physicalism by saying that there are different kinds of sound. The sounds we encounter in everyday life might be physical things or events, but the sounds we hear in music might be something else entirely.
That's a really cool idea. So where does all this leave us? We've gone from sounds being in our heads to sounds being vibrations in the air to sounds being at the source and even to sounds not being anywhere at all.
It's a whirlwind tour of sound, that's for sure.
It really is. And it's clear there's no easy answer. Philosophers are still debating this stuff.
And that's the beauty of it. It makes you think, right?
It does. And as a philosopher, I bet you're wondering which theory is right, which one makes the most sense.
I am.
It's a tough call. But here's something to think about. What do these theories tell us about things like music and language? They're built on sound. So if sound isn't what we think it is, what does that mean for them?
Right. If sounds aren't really located where we hear them, or if they're not physical things at all, it changes how we understand these fundamental parts of our lives.
It really does. It makes you realize how much we take for granted.
It does. So, listener, what do you think? What is sound? It's a question worth pondering.
It is. And maybe, just maybe, it'll change how you listen to the world.
You never know.
All right, that's it for our deep dive into sound. Thanks for listening.
It was a pleasure.